In this video for Lacerna's review number 2 for the Unit 4 test, I'm going to look at numbers 9, 10, and 11. I'm actually going to kind of go out of order. I'm going to do 9 and 11 first because they're both the proofs, and then finish with number 10 later. So number 9, we are given that quadrilateral math. There's quadrilateral math shown below is a parallelogram. So we've got, number 1, the very first reason, always the easiest, is given. And before we go through all of this stuff, before we go through all the middle stuff, let's look at what we're ending with. They want us to prove that triangle ATE is congruent to triangle HME. What I would suggest is actually, before you start to worry about this stuff, really pay attention to what triangles these are. Because especially when you have these diagonals drawn, there's a lot of different triangles in the picture. There's actually 3, 4, 5, 6, I think there's 7, actually 8 triangles that you could really deal with here. But we only really want to concentrate on these two. So triangle ATE, I'm starting at A, highlighting to T, and then to E and back. So there's triangle ATE. Triangle HME starts at H, goes to M, up to E, and then back to H. So those are the two triangles I'm dealing with, which means I don't want any angles inside these triangles. And that's one thing that's tough when especially when you're filling out these. So I've got these two triangles I'm trying to get congruent. Now number 6, this should be SSS or ASA or AAS or very rarely used HL, which remember HL only worked on the right triangles, so I'm just going to go ahead and cross that off right away. And then, oh, I almost forgot SAS. It's got to be one of those. Now if we start to go through the proof, the second statement tells me AT is parallel to MH. On the test, you will be graded on how you mark this diagram. Now, you don't have to highlight it, but you do have to mark these based on what they're giving you. AT parallel to MH. AM parallel to TH. Now, notice, as I do that, the arrows are on, there's 2 arrows on the highlighted, 2 arrows that are not on the highlighted. We're really, again, concentrating on just the highlighted part. So chances are I'm not even going to need those on the left and the right. Now for number 2, the reason that we know that these are parallel is because they told us that we were given in the beginning that it was a parallelogram. One thing we know about the parallelogram is the definition, which states that the opposite sides are parallel. Definition of parallelogram. Now we look at the next one, and notice there's nothing marked congruent yet. We don't have any congruent parts yet. We just have parallel lines. Number 3, AT is congruent to MH. Put a dash on AT and a dash on MH. In a parallelogram, opposite sides are congruent. That is a theorem that has been proven. So now we finally got a pair of sides that are congruent. So I'm going to put a little S there. And number 4, if lines are parallel, then alternate interior angles are congruent. This is now when the highlighting really comes into play here, because with the highlighting I can see, remember, for alternate interior angles we're looking for a Z pattern where you have the inside of that Z being congruent. There's actually 2 different Z's we can find, where there's one going normal direction and there's a backward Z like that. If I look at the normal direction like this, I'm going to highlight, kind of draw over my highlighting. There's one angle inside the Z there at the top, at T, and there's another one down here at the bottom. That is my alternate interior pair. Now if you use the backward Z, you could also use this angle and this angle. It's really all about how you're naming them. Now you have an option here with the naming. You could say angle ATM congruent to angle HMT, or you can number 1 and 2 and just say angle 1 congruent to angle 2. The test will actually have it written out for you. So on the test, they're going to give you all these things. You have to decide to put them, you have to put them in the right place, in the right order. But here I can make it a little bit easier. Label 1 and 2, then I've got angles 1 and 2. Now again, this is an angle. I'm going to put an A there for angle. Statement 5, reason 5, statement gives us angle AET congruent to HEM. AET is this angle, HEM is there. That's a vertical pair, and notice that they're inside the highlighting, and that's what we want. Vertical pair means vertical angles are congruent, would be our reason. And then number 6, to choose one of these, notice that so far I've got the side, the two angles marked, I've got two A's and one S, which means it's not SAS or SSS. It's got to be one of those two, ASA or AAS. And remember, to determine that, if it's ASA, the dash, if it's ASA, has to be between the two arcs, between the angles. This dash is not between those. So this one is actually going to be angle, angle, side. That's the one that works. Now switching gears to number 11. Very close. Now notice in number 11 it's a little bit different because they don't have that other diagonal drawn. They only have one of them. Given ABCD is a parallelogram, there it is filled out for you already. Prove triangle ABC is congruent to triangle CDA. That, as soon as we see that next to the word prove, that goes right here at the bottom. That's the last thing we should be saying. Triangle ABC congruent to triangle CDA. So now, like last time, I'm going to highlight those two triangles so I can see where all the parts should be. Triangle ABC is this right here, and then CDA starts at CDA. So now I've got those two triangles. Now notice how different they are. On this one, those triangles were kind of inside the parallelogram. Here it takes up the whole thing. So it's a little bit different for the parts that we're looking at. Now number 2 is going to be a lot like this one. They're stating the parallel sides, BC parallel to DA, AB parallel to CD, definition of parallelogram. So that's not different at all yet. Now we get to the third statement, and this is the only thing they have in there. There's a lot of space. It's the only thing they have. Angle BCA congruent to angle DAC. BCA, if you can find it in here, BCA is at C right here on top. BCA is this angle. DAC is this bottom angle. Now when we drew those two, that gave us our Z pattern. In other words, gave us alternate interior angles. Alternate interior, I'm breathing in a lot, angles congruent. Now there's completely blank statement 4 and reason 4. If we look ahead to statement 5, AC congruent to AC. AC congruent to itself, that's reflexive property. That one we did a little lot in class. Reflexive property, whoop. So now it's just dealing with what are these two here. So we've got in one triangle, I've got an A for the angle, I've got an S for the side. So I've got to get either one more side or one more angle. And the way it's kind of set up for us, they told us about these parallel lines. That gives us one more Z pattern, one more alternate interior pattern. Here at the top of A, here at the bottom at C. This angle is BAC. Angle BAC. Look how close it is to this name. All that's happening is that those letters are switching. Then the second one over here is DCA. DCA. Again, same thing happened. Those letters switch. That's the only difference, but it does make a big difference for what you're marking here. For statement 4, alternate interior angles is the same kind of reason. Alternate interior angles congruent. Oops. Now the very last reason here, again, it's like this side, it's going to be one of these properties. I got my other angle there. Now I have that side in the middle. Remember last time the side, the dash was not in between those arcs. This time I've got the arc, the dash, the arc, it's in between, which means ASA works for this one. And remember on the test, when you do take the test, you will get graded for marking the diagram as I've marked it here. You will get graded for having all this stuff in the right order. Last one for this video, number 10. Given the parallelogram below, state all the properties of the sides and angles. For the sides, let's look at these are all the angles. So A and C are congruent. These opposite angles are congruent. A and B are, and I'm abbreviating, supplementary. Consecutive angles add up to 180. B and D are congruent. Those are opposite. A plus B plus C plus D, adding up all 4 angles in the quadrilaterals, and any quadrilateral gives us 360 degrees. Now the other properties for the sides, if we just mark the sides, I think that would be sufficient here. If we can say opposite sides are parallel, that's one property. The other property is that the opposite sides are also congruent to each other. So those marks should do the trick. Those marks show us everything we need to know about the sides. This tells us about the angles.